Welcome to episode 5 of the Don Paul podcast. Today's topic: why we know it's us, not nature, that's causing global warming. It is a constant cry of many climate change denialists that the Earth's climate has always changed throughout its geologic history. There have been tropical periods and ice ages and back and forth, and yes, there is truth to that. However, we know that before the onset of human activity, these ice ages and tropical periods were tied very closely to the eccentricities, the irregularities in the Earth's orbit, which are predictable, which have been studied over tens of thousands of years. The Earth's orbit goes from an elliptical shape to a more nearly circular shape and then back again. And these different orbital shapes tend to adjust the amount of solar energy input reaching the Earth's surface. Paleoclimatologists are scientists who dig down through ice cores and sediment going back hundreds of thousands of years and can find the precise tie-ins between these elliptical periods and ice ages and tropical warm-ups. And the correlations are quite clear, peer-reviewed, evidence-based, and pretty much set. What we also know from these orbital irregularities is that at this time in the Earth's geologic history, were it not for human influence, the Earth should be cooling at this time. There is no other explanation for the warming which has been accelerating since the 1980s on an uneven rate, but going up, other than human activity. And that's not to say in any way that human activity is purely a bad, evil thing that we all do as citizens around the world. Of course, the Industrial Revolution has brought great improvements to humanity's lives, expanded food production, and so on and so forth. But we're now reaching the point where the amount of fossil fuel burning continues to be at a rate which puts out more and more carbon dioxide, and that also results in more and more methane getting into the atmosphere, which are potent greenhouse gases that are outstripping nature's ability to absorb the extra carbon in the atmosphere. The ocean actually has absorbed more than 90% of the carbon dioxide in the Earth's atmosphere, and it's stored in that water. The problem is the rate of warming is warming the oceans as well as the land and the atmosphere. And as the oceans warm, they will be releasing more of that CO2 right back into the atmosphere, creating more of a greenhouse effect. Moreover, the oceans are not just warming at the surface, they're warming near the ocean's seabeds. And the seabeds contain, underneath the oceans, vast quantities of methane. And as the seabeds are heated by the warmer water, this methane is being released into the atmosphere. Methane is a very potent greenhouse gas, about 23 to 38 times more potent than CO2. It doesn't have the same shelf life in the atmosphere. It doesn't stay in the air as long, but it's being replenished constantly. And the CO2's induced warming has also caused thawing in not just the seabed, but in the tundra. Permafrost is thawing. Huge amounts of methane stored in the frozen tundra now being released into the atmosphere. Methane produces more warming. Warming begats warming. There are these feedback mechanisms that are not in the future, they're now. And the question will be whether they worsen or whether we can slow them down and stabilize them. And that's going to depend on moving toward a zero carbon economy by about 2050, reducing it sharply by 2030, but then in gradual steps and improvements, getting us to a point where we would no longer really be burning fossil fuels by 2050. That would slow down the rate of warming and also slow down the rate of methane release. And of course, there's also the methane being released from fracking operations and natural gas operations. But in the meantime, not all hope is lost. There is a certain doomism that sometimes pervades social media in which an assumption is made that we've passed a tipping point already, and there's no turning back now. That's not the case if humanity, I don't just mean the United States, moves more aggressively to reduce the burning of fossil fuels. There is good evidence that if we were to reach a zero-based carbon economy, the rate of global warming would slow to a crawl and give us a best case scenario later in the century rather than a worst case. And there's a huge difference in the impacts. Remembering that rising sea levels are one of the key impacts from this warming, 30% of the world's population lives on coastal floodplains. And as the ocean slowly inundates certain areas, actually, there are already some cities in Southeast Asia which are considering relocating because of water beginning to overrun runways at airports. And of course, there are the problems of South Pacific Islands. The rate of sea level rise in a worst case scenario would cause much more massive migration of coastal residents to get away from the inundation, as opposed to slower rates of rising sea levels. And again, that's another impact that's not in the future, it's here now. For example, Miami Beach has had to spend billions and billions of dollars to dig up streets, resurface them, and elevate them because Miami Beach, as do quite a number of coastal cities, suffers from what's called sunny day flooding. Sea levels have already reached a level so that when the highest tide in the month, the lunar tide, brings the tides up to the maximum, not connected in any way with an ocean storm, there is flooding occurring in cities, and that's why it's called sunny day flooding. But that rising sea level also exacerbates the impacts of storm surges from nor'easters and hurricanes. And so the problems are already here. There's no longer a question of when do they begin. They've been here a while and they are getting worse. So it is up to us. And I do want you to know that everything I'm telling you here is derived from consensus science, not from Don Paul. And there's a great website that I frequently turn to that's written by world-class climate science communicators for laypersons, not for other climate scientists. So it's quite readable. And it's a site called climate.nasa.gov. That's climate.nasa.gov. If you forget that, you can just put in a search engine, NASA climate. It'll pop up. And if you put in climate.nasa.gov and then turn to evidence or just find evidence on the homepage, you'll find much more than what I have the time to tell you here. But this is no longer speculative. Unfortunately, there are denialists who base much of their positioning on political ideology, which has nothing to do with the physics. It has nothing to do with the chemistry. It has nothing to do with the geology. That terrible, almost meaningless phrase, "it is what it is," really does apply to the evidence which is in place. It's no longer really a question. It's not from more solar energy reaching the Earth. In fact, solar input to the atmosphere has gone down slightly in the last decade. It's not from nature, it's from us. And we also face the challenges of nations such as China, who are playing both sides of the streets. China is perhaps the leader in solar technology. They undertook that path for two reasons. One, their solar technology makes a lot of money. And two, they were having the kinds of air pollution episodes around some of their largest cities that London and the United States used to have back in the 1950s, with a large number of premature mortality figures rising in many of these air pollution episodes. But they're also still building new coal-fired power plants due to the very size of their economic base. And worst yet, they're exporting coal-fired power plants to third world nations that now have developing economies in Africa and other parts of Asia. That's what I mean, playing both sides of the street. They have made some commitments to improve their input into emissions, but they're nowhere near where they should be. India also is a major contributor with their rapidly growing economy. As for the United States, we have had some improvement since the mid 1990s. Some of that is tied to the economics of switching from coal fired power plants to natural gas. Natural gas still results in the emission of carbon dioxide, but much less than coal, about 40% on average of what coal produces. So it's nowhere near perfect, but it has led to some reduction. And now transportation has actually surpassed power generation as the largest uh, source of greenhouse gases emitted in the American economy. We also have agricultural technology, which makes huge contributions to methane and carbon dioxide. And there will be changes coming eventually in those areas as well. So for now, climate.nasa.gov. I hope you've enjoyed this episode, gotten a little something out of it. If you have, please share, and very important, please follow. And I'll be chatting with you again very soon.